Welcome, everybody, to the Momenta Partners webinar focusing on low power, wide area technologies and opportunities. My name's Ed Maguire, and I'm the Insights Partner at Momenta Partners based in New York. A little bit of my background: I've been a research analyst on Wall Street for roughly the last 17 years, and I've been working with Momenta over the last year to help businesses navigate their digital transformation journey through integrated advisory, executive search, and ventures practices. So first, a little bit about Momenta Partners. Who we are is Connected Industry Growth Partners with leading strategic advisory, executive search, and investment practices that accelerate growth for connected industry companies since 2012. We have a team that consists of deep practitioners that have led connected companies in business lines at Apple, Brambles, Daintree, Eurotech, GE Digital, IBM, ThingWorx, Wonderware, and many other companies. We've been the guiding hand behind leading industrials IoT strategies. We helped with the largest IoT transaction of 2016. It was a $1.7 billion deal. We've done over 150 IoT leadership placements and growing, and have worked with and invested in over 25 young IT disrupting startups. And we've got an active stage investment practice, and we're focused on increasing investments within connected energy, manufacturing, supply chain, and smarter spaces, as well as emerging technologies like artificial intelligence and blockchain. So just a little bit of housekeeping. If you have a question, look at your control panel. You'll see a box where you can submit a question. We will have plenty of time for Q&A at the end, and we'll be looking forward to taking your questions. I want to first introduce our webinar panelists. So one of the things that we try to do at Momenta is really source some of the smartest minds in the industry. And for this webinar, we've tapped the talents of three experts. Daniel Quant, who is a VP of Strategic Development at Multitech, brings over 2 decades of experience in wireless and telecom, including 20 leading product teams, and he was formerly a VP of Product Marketing at Telit and Director of Business Development at Setcom Wireless. Domenico Arpaio is the CEO of OrbiWise, and he also has over 2 decades in the wireless industry with a broad range of management positions in research and development, business development, product marketing, and has worked in IP licensing, operator relations at ST Ericsson, and many other senior roles at Ericsson. Paul Fulton is the CEO of Enwave with, again, more than 2 decades of experience in communication software and solutions that work with both domestic and international markets. And he's been formerly the CEO of Zentry and VP of products at Mocana. And he also has testified in front of congressional subcommittees and is well recognized as an expert. So to provide a bit of structure for our webinar, we will have an overview of the topic, which I will provide. We will hand the mic over to Daniel Quant, who will talk about the many faces of low power wide area technologies. Domenico Arpaio will highlight LoRa, and Paul Fulton will provide some insights into some case studies focusing on connected parking. And after this, we will open up for Q&A from all of the panelists. So first of all, when we look at what low power wide area networks are, the question really is what does define a low power wide area network? And they really are simply technologies that are able to connect the type of sensors that we use for Internet of Things use cases, in a very cost-effective manner. With billions and billions of devices and sensors coming online, the need for these types of solutions is quite apparent. The low power aspect of LPWA, as we'll call it, is really to focus on environments where there is no power connectivity. A lot of devices need to operate for up to several years solely on battery power. And then in terms of the wide area capabilities, this refers to systems that will allow sensors to connect in areas where there's low base station density. So this is really critical for servicing rural areas and remote areas at very low cost. So a little bit of background, and really the reason why low power WAN technology is so important. Wireless connectivity is absolutely critical to drive the adoption of connected devices, connected solutions, and really to enable new business models. And it's this connectivity component, again, that's also critical for to realize the ability to derive value from the data that gets generated at the physical edge. Now, traditionally, a lot of the what are called mobile to mobile applications, or MTM, have used 2G and 2.5G cellular networks. And over the last several years, this area of M2M communications was not in the front lines for most big carriers, and didn't get a lot of focus at the same time as we had growing interest in connected industry solutions. There have been a broad number of startups with different types of technologies that have been using unlicensed spectrum in order to address these gaps in connectivity. And on the mobility side, the traditional carriers are actually leveraging this technology in what's called narrowband IoT, or what's known as NB-IoT. So what is good about low power WAN technologies? Well, one is this ability to provide much broader coverage. You can get ranges of 2 to 10 miles. Battery life can last up to 5 or even 10 years. And this from chipsets that are much cheaper, more economical to produce and to acquire. When you're acquiring a lot of devices, it certainly helps to be able to pay less than, say, $20 per endpoint per year, or even far less. Also, the ability to cover these remote areas, farming areas, or even in emerging economies. If all you need is a few readings from a sensor, say a temperature sensor or agriculture sensors, you don't necessarily need high power, high performance networks. Now, the ability to use unlicensed frequencies also provides an enormous amount of flexibility to these types of networks. And the key appeal to low power wide area technologies has been the ability to reduce costs of deployment and maintenance, frankly, because a lot of the endpoints are not as complex, they're not as expensive. And the key trade-off here, of course, is that you do have lower throughput. There have been several estimates in terms of how big the market is going to be, and on this slide we show really several areas that or several market estimates that do give you a little bit of a sense of really how big this market could be. Now, Analysys Mason has predicted that we could see up to 3 billion mobile-to-mobile connections worldwide by 2023, and these connections could potentially grow, or I'm sorry, the services, could be over 10 billion by 2023, and you could have over 5 billion LPWA connections by 2022. So interestingly, a lot of the growth is forecast to come in the Asia Pacific region, but we also have a lot of activity in Europe and the US as well. Many carriers, many players in the space are actively looking at this market. And then when we look at all of the connectivity options, when you're looking to put together a connected industry solution, we really are in many respects spoiled and potentially confused for choice. And what this slide provides is really an overview of many of the different options and connectivity options, ranging from the really the most closely bounded types of networks we call personal area networks, where we use Bluetooth or Z-Wave or Zigbee in the home, where you have local area networks, typically that use Wi-Fi, metropolitan area networks that are much broader, and then wide area networks, which is what we're very much focused on in this webinar, because there is such a broad range of connectivity options. These are typically applicable to applications where the lower cost can justify lower bandwidth, and there are many current choices, which we'll get to in a bit, and we're going to look to examine some of the trade-offs in the context of actual use cases. Now here we got a few examples of where we would need local area networks that have higher bandwidth, obviously offices, personal networks and wearables, augmented reality and virtual reality demand higher bandwidth, and also point of sale devices. If you look at certainly on the industrial side, connected meters or agricultural sensors for watering, bike sharing applications, even energy and weather sensors. All of those don't necessarily need high throughput always on connections. So the wide area IoT scenarios definitely lend themselves to much more flexible and lightweight options. Now, if we look back historically at the market, we can see that roughly every decade we've had pretty significant advances in connectivity options and and different types of connectivity, or different types of devices as well that drive the demand and also the endpoints that create data. So as we've as really we move from the current decade into the 2020s, what we're moving from is essentially an environment where, for instance, LTE and a very robust IP core that support a lot of video and broadband data are moving into an environment where we're going to have very almost not ubiquitous, but more widespread broadband connectivity, much higher demand for HD and super ultra HD video, as well as much more demand for very low latency responses when we think about edge computing applications. And there's going to be a lot of use cases that emerge again, where the heavier and greater throughput networks are really overkill. And that's why we're seeing this really an explosion of different low power wide area options. So what's confusing is that there are many criteria involved in looking to choose which technologies or sets of technologies are the right ones. And in this slide, you can see that making a decision really can involve multiple factors in a number of different dimensions. So it's quite a bit of confusion. I mean, if you start to look at the comparisons and match them to the needs of your systems, these can be overwhelming. And that's part of the reason why we held this webinar and why we're tapping experts like Daniel Quant, who will provide us an overview of his perspective and expertise and shed a little bit more light on these technologies. And with that, I'd like to hand the call over to Daniel.
Thanks, Ed. You hear me okay?
You sound great.
Right, well, it's a pleasure to be here today. Next slide. So Multitech develops and manufactures industrial IoT communication equipment, which goes into a number of vertical industries, many of them highly regulated. So oil and gas, utilities, distributed energy resources, smart grids, and renewable energy, where Enphase has been a great partner of ours. We've also been selling for many years into the medical business, and here we have an image of a defibrillator. We sell communication equipment into a number of different defibrillators, and then the patient's data records are then waiting in the ER room when they get there. LoRaWAN has really enabled us to innovate, particularly around precision agriculture and smart cities. Again, Waterbit has been a great partner for us in that precision agriculture. ChargePoint and P&I Sensor Corp have enabled us to expand much more into smart cities. Next slide, please. At Multitech, we see three types of connectivity, mainly for wireless, which is where most of our customers are really moving now. So we have the LAN short-range stuff, Wi-Fi's, Bluetooth, Zigbee's, wireless M-Bus, you know, the list is a long one, as Ed pointed to. But if we take Wi-Fi, right, I got an internet connection in my house. I went to the shops, I bought a Wi-Fi access point, I put it in. My friends and family, they come around my house. I'm not paying anything more to use that because I did a CapEx. I bought cash money, the access point, and I put it in. And businesses have been doing that for many years with Wi-Fi, and it enables them to get a very quick return on their investment. Of course, if you go into my garden, you probably don't get a very good signal. And that's where, over the last 10 years or so, cellular has done a great job of ubiquitously covering the entire world. And container shipments is a great example of that, right? Coming into ports all around the world and understanding how your goods have been treated, what they've experienced, and where they now are. Of course, the downside to cellular, as we all know, is we have to pay for every device for every month for the life of the product. Whereas with low power wireless access, we get to flip that. We get to turn it on its head. Essentially, it becomes a paradigm shift. Next slide. And that's because we're able to get long battery life. We're able to get deep in-building coverage and great link budget and line of sight range. We get lower cost, and of course everybody loves that. But what's the trade-off then? Well, the trade-off is you don't quite get the data rate. You get perhaps a few kilobytes per day of data. But it turns out that 75% of industrial machines out there consume less than a meg a month. They're not on YouTube like us. They've got very focused bits of information that they send, and it's reasonably infrequent, generally once an hour, once a day, and it doesn't add up much at the end of the month. It's also interesting to note that LPWA technology can be deployed in licensed bands as well as unlicensed bands, and that enables a much broader set of applications. We can now be very flexible on the business model between OPEX and CAPEX and really get that TCO down. We can also provide very mission-critical secure connectivity. Next slide, please. Looking at LoRaWAN, we see great coverage of the world now. So the tier 1 industrial nations and the tier 2 developing countries have broadly embraced low power wireless access, particularly LoRaWAN. And it's not just about Comcast and Orange. These countries all have private LTE, private LoRaWAN deployments in them, which are very CapEx strong and provide that broad set of use cases to be realized in different use cases. Interesting as well, LoRaWAN is now well over 500 members and is having an all members meeting next week in Vancouver. I look forward to seeing you all there. Next slide, please. So there are three types of mode of operation of a LoRaWAN device. Now remember, LoRaWAN is a greenfield technology. It's not carrying 20, 30 years of cellular technology behind it. So it's addressing initially sensor harvesting, which is called Class A mode. And in Class A mode, the device is asleep for 99% of its life. It only wakes up when perhaps the temperature gets too high and it has something to say. And when it wakes up, there is no complex PDP or IP connection to substantiate. Instead, the message is sent, the access points and gateways around that sensor receive that and send it up to the head end or the IoT platform. Class B mode enables the device to wake up and listen at predetermined periods of time. So the network knows it's going to be there and it listens, which consumes less battery than transmission. And if the network has something to say, then it can hear it. For example, turn on the irrigation equipment or turn on an engine. And then Class C mode is for applications that are running off a mains power, and that works much like a mobile phone. You're always on the channel, so you're always listening for when a downlink paging message or what have you is coming in, and you can get on channel whenever you want. Next slide, please. When we look at low power cellular licensed technologies, we see a very similar split between the developed countries and the industrial countries. But it's interesting to note that the West typically started off with LTE CAD-M and the East with narrowband IoT. These networks are all now combining to have both of these license band LPWA technologies because it enables them to maximize the number of use cases and grow the subscription on their networks. Next slide, please. Like LoRaWAN, it's the same issues. It's all about battery and range. So the guys at 3GPP, they've reduced the complexity of the protocol stack down considerably. Instead of flying at 40,000 feet, perhaps they're down at 10,000 feet now. And things like power saving mode is a great example of that. That just like Class A mode, the device is 99% asleep up to 3,000 plus hours. And when it wakes up, that PDP context and IP link already is created, and it can come immediately on channel very efficiently and get its payload across. Like Class B mode, there's extended discontinuous reception, where the device can periodically wake up, maximum of every 44 minutes, listen, make sure that there's nothing coming on the downlink, to turn on an actuator or do a firmware update. And if there's nothing, go straight back into deep sleep again, thereby saving battery. The extended coverage, mode A and B, maximizes link budget. And it does that by different coding schemes that add in more redundancy into the data, retransmissions. Can you hear me? Can you hear me? Can you hear me? Eventually, maybe the endpoint can hear the network or vice versa. And then modulating the same amount of energy into a narrower bandwidth signal to essentially punch through further, thereby getting 15 to 20 dB of link budget improvement. Next slide, please. At Multitech, we've been selling now LPWA technology for, at least 4 years with LoRa and for the last 12 to 18 months with the cellular equipment. And we see consistently the same types of design wins coming into us and from our customers. And with LoRaWAN, that typically is around things like tank monitoring, leak detection, facility management. That could be anything from hand sanitizers in the bathroom to meeting room occupancy, heating, ventilation equipment, smart parking, in precision agriculture, and also preventative maintenance. And what do all these applications have in common? Well, they all have the ability to be deployed at a much, much lower TCO on the grounds that maybe if you didn't get a message once in a week, maybe you're transmitting once an hour a message, and once in a week there's a packet clash or an extra bit of noise somehow in the channel and you didn't get that message, it's not the end of the world. Look at preventative maintenance, for example. If you're monitoring the temperature of bearings in an engine so that when they get hot some years down the line, you know to send somebody out to fix that machine before it goes wrong. Well, if you missed a message once in a week, probably not the end of the world, right? And you can dramatically reduce your TCO for that. Whereas conversely, on cellular, we see a lot of applications that really embrace the complexity of the protocol that still exists in cellular, and the fact that it's in a more managed license band spectrum to address more mission critical use cases like asset tracking, healthcare devices, industrial equipment, for example. So last slide is a bit of a candy chart that shows a number of different LPWA technologies, and you can read this in your leisure after the webinar. But what it's showing is that Sigfox is very well positioned at low power sensor harvesting, which is quite possibly one of the biggest use cases in IoT. LoRaWAN also does that very well, but almost like an aperture in a camera. It can grow the size of the aperture to accommodate a lot richer set of use cases, even things like digital signage. Whereas the cellular license band technologies are still much more focused because of that beefier protocol stack, quality of service, 4G latency that can be achieved, much more focused at mission critical applications. And with that, I will hand you over to Domenico at OrbiWise.
Okay, thank you, Dan. We can go to the next slide directly, Ed. Thank you. I'm Domenico Arpai. I'm CEO of OrbiWise, and which is a Swiss company focused primarily on LoRaWAN. Our core product is OrbiOne, a complete network software solution for the IoT networks based on the LoRaWAN standard, as I say here in the slide. Thus far, I would say we have focused primarily on medium and large size networks and customers. So our core product supports all the features of the standard and has the scalability and advanced network management features that customers have come to expect of cellular type networks. In the next few slides, I will briefly speak about the LoRaWAN protocol and the LoRa Alliance, and then I will give an example of a large deployment, and then discuss a few interesting applications that are emerging in the LPWA space. And if you can go to the next slide, we are already there. Okay. In my experience, once a new technology has the key features to gain widespread acceptance in the market, its success is determined more by the ecosystem and the market dynamics of this technology than by this or that particular feature. The LoRa Alliance has been instrumental, I can say, in the success of the LoRaWAN standard. It has more than 500 members, as Dan mentioned before, with about 100 contributor and sponsored members. Getting started in 2015, we were one of the early companies with Multitech to form and join the Alliance. As you can see in the slide, there are large global companies as well as startups in each part of the value chain and most verticals. The LoRaWAN standard is continuously evolving, with new features being defined and supported by all members, which is crucial for the vitality, I would say, of the standard in the long term. And such a large community means also that there is a large product selection, which is crucial for cost-effective solutions. As my friend Dan mentioned before, I will say that we have all member meetings once a quarter, quite large meetings, and we have the next one in Vancouver, in fact, next week. Next slide, please. I will now give just a few highlights of the standard. I think Dan already mentioned about device classes that are supported. So briefly, is the class A with asynchronous uplink, which really supports the lowest power consumption devices. Class C is primarily for power devices, whereas Class B is used, really uses a network beacon and finds application in many cases requiring timely downlinks, like it happens in many applications involving actuators. The standard supports dynamic link adaptation and a number of sophisticated radio features in the protocol with power control, spread factor adaptation, and other features. There is a network-based geolocation is possible. Network-based geolocation of devices is possible and supported by us and a few other network software providers. It does not require GPS or other location sensors, and so it opens up many geolocation use cases with ultra low power devices. Some use cases that are really have not been possible so far. Roaming is also standardized by Alliance, supported by us and a few other network software providers. Firmware over the air, which is so crucial and important in many verticals, to be able to update the firmware in devices remotely, is also being standardized now, and there are already some versions available. Finally, I should mention that the Alliance supports a device certification program that was established a few years ago and really has helped a lot in the growth of the device ecosystem. Now there are hundreds of LoRaWAN devices already available, which can greatly simplify the deployment of solutions in many verticals. Next slide, please, Ed. This particular slide shows a simplified architecture for a typical LoRaWAN deployment. The network server covers all the MAC features on the network side, and it includes all the network management functionality, which can be rather sophisticated, especially in large networks. In our case, the network server can be scaled both vertically and horizontally via distributed databases with either on-premise installations or via SaaS model. We support both models. Our network server also can be deployed on few virtual machines or even in one virtual machine in some enterprise cases that require it, as well as in large clusters when we support public networks. Notice how all the network elements interoperate with each other, which, along with the large selection available that I mentioned before, really stimulates competition in the ecosystem and makes it possible to have cost-effective solutions, which at the end of the day will be the name of the game as we deploy these billions of devices that we all talk about. Next slide, please. And yeah, thank you. I will now mention briefly about one large LoRaWAN deployment using our Orbi-1 product. And in fact, I think it is the largest LPWA network in the world. It's the Tata Communications nationwide deployment in India. It's already covering, I think, all cities with more than 1 million people in India, which in India is a lot of cities. There are a lot of cities with more than 1 billion people, I think about 50. And it's well on their way to reaching 9,000 outdoor gateways in 2018. And as you see, by 2020, they expect to have over 16,000 outdoor gateways. It's really helping in this case. I will say that the Tata Group is a large conglomerate where many companies in the group, such as Tata Steel, Tata Power, Tata Mining, can make use of the network. And so they can load the network with their own devices. There are more than 40 verticals qualified, including metering, worker safety, asset management, smart lighting, and many others. I will not really mention kind of cases that are very well known. If you can move to the next slide, please. I will focus really on a few examples that are really more specific to LPWA networks and really enable new applications that are really enabled by the LPWA paradigm. One such case that I would like to highlight with Tata as well is employee safety in terms of monitoring employee health and safety in the workplace. As you see, the statistics is quite an interesting subject where there are hundreds of millions of work-related injuries and illnesses each year with, I would say, a large human cost and also a substantial impact on GDP. I would say with the business leaders I talk to and executives in many customers' companies, many companies that we talk to, that we work with, there is growing awareness among their business leaders on this problem in many industries. In this particular example, Tata Communications has developed a low-power smartwatch with LoRaWAN connectivity and a number of sensors that you see mentioned on the right side, which helps detect employees' safety problems in a timely manner. And I believe this is being deployed in Tata Steel and also Tata Mining sites, where, by the way, it would be impractical to use any other radio communication technology. We have other cases of LoRa being used in these mines type of applications. Next slide, please. I would mention two other examples. The first one is, in fact, very close to us and very dear to us. It's acoustic noise pollution monitoring, which is actually regulated in the European community as well as in Switzerland. So far, there is no simple way for cities to monitor compliance to regulation, in fact. And some cities end up hiring dedicated staff to make few measurements every year with expensive equipment typically, and build complex 3D models to have only partial compliance to the standard, by the way. With LoRaWAN connectivity, one can build small battery-powered devices that will measure the main features of acoustic noise in real time and report measurements to the network via the wireless connectivity. We started this project as a pilot really in Geneva last year with roughly 1,000 devices, but we're now getting a lot of requests everywhere, not only from cities, but for deployments in airports, highways, etc. And so now we're planning to industrialize this device with additional features and energy harvesting. Next slide, please. And to conclude, actually, one last application I would like to mention is an interesting application of the LPWA paradigm is the monitoring of drinking water in the water distribution systems of a city. The challenge in this case is to establish a radio communication link between a sensor under the asphalt and gateways that can be, in some cases, kilometers away. The radio link budget of LoRaWAN really allows for such radio links while maintaining the low power requirements for devices. And in this case, the device developed in cooperation with the University of Geneva and the local utility measures turbidity, chlorine residual, as I mentioned, there are a few other parameters. It's not quite a mass market device, I will say, but it's certainly another example of interesting application emerging thanks to these new technologies. And I will stop here and I'll hand over to Paul Fulton.
Okay, great. Domenico, thank you. I appreciate that. And it's a pleasure to be here. And Ed, thank you for having me here. Just doing a sound check, making sure everybody can hear me.
You sound great, Paul. Thank you.
Excellent. Great. Okay, so we're going to do something a little bit different. We're going to talk about LPWAN, but we're going to dive into a specific vertical and talk about how this technology is helping solve a problem that's been around for a while. So a bit of a deep dive on smart cities and parking, and then a little bit of talk about the technology. So let's go ahead to the next slide, Ed. So smart cities is one of the largest deployments, and Ed, my slide still hasn't moved yet, so just checking. So smart cities is one of the largest deployments of IoT because there's large problems to solve here. And we're going to specifically talking about one of those vertical applications within smart cities, which is parking. And, you know, this is a topic I think we can all think about, right? We're all drivers and we can all understand the issue of just not finding a parking spot. It's very painful. It's a very big waste of time. We're looking around, we're circling. It's been estimated that 30% of urban traffic are drivers just looking for a spot. And of course, sometimes some people don't even go some places because, you know, I'm not going to go to that concert or that event because I just have too much anxiety finding a spot. But, you know, the bigger problem actually are the owners, the owner of real estate. So these are very, very expensive assets. And we're trying to manage these assets without data. It's kind of crazy. If you think about how airplane seats are managed, imagine doing airplane seats without understanding if the seat's occupied, or think about a hotel room, going and finding somebody, you know, quote unquote, parking in your room. You know, so we really, really need to have data. And the problem is that data has been just too expensive to get this market to take off. So let's go ahead and the next slide. So it's a big problem. This is just US numbers, and I apologize for that, but globally these numbers are huge. But there's a huge opportunity here for the specific market. There are a lot of customers. The customers are in municipalities, in private enterprise, with garages and universities, hospitals. And just looking at this market, this is a big enough customer base to have a thriving business market for multiple companies to address. And let's go to the next slide. So there's several ways to attack this problem. And a lot of these technologies have already been used, but let's just briefly go over these. And this is a chart, pretty easy to understand. On the top is just lowest total cost, high cost on the bottom, lower accuracy on the left, higher accuracy on the right. And if we start with mobile is, we all have mobile phones, and it's a great opportunity to say, hey, let's leverage some of the data collected on these mobile phones, what we usually call data exhaust, which is great for, say, traffic patterns. But the problem is, to actually monitor open spaces, you have to have an app open. The app has to be installed, and we frankly just don't have enough of data to provide a high enough accuracy. So that is running into issues. On the lower left-hand side, we're talking about video. Video is a wonderful technology, a lot of advances in last years, but it's really only good for open spots, not great for garages. It requires too many cameras, not great for open streets, parking as well. And then, of course, requires a high bandwidth connection, so it gets expensive. On the lower right, radar and LiDAR, highly accurate, great technologies. However, their power consumption is high, and so they require a lot of power. A lot of times they're put into street lights, and street lights aren't where all the parking is, and so deployment costs get high. So that leads us then to ground-based sensors, and where LPWAN comes in. Let's go to the next slide. So nWave leverages low power wide area network because it's the right technology and it provides the right technical trade-offs. We absolutely need low power. These devices need to be installed, and they need to last at least a decade. We need long range because street hardware is expensive to maintain, and we want to have very little street hardware as possible. And of course, we need real-time access to provide that data. Now, one of the issues that we found is that we picked a standard called Weightless N, which we're one of the authors on, that allowed us to do this specific application in a much better way than the other technology options. So, for example, we have fine-tuned the protocol to allow us to have great coverage, very, very large coverage. And in fact, we have a spectral efficiency that allows us to have a 10x better efficiency. This means that our batteries are smaller, our batteries last longer, and we have a longer distance. And in fact, we also have more base stations, or more sensors per base station, up to 20,000. And it's not just about deployment cost, because this is the friction that stops this market to go. We needed the lower cost to do. But frankly, if you're wasting 90% of your battery power on a protocol that just doesn't fit the market, it's just not good for the environment. So it's really important to understand that. One last point on this is, while carrier-based networks are great for specific applications, in our particular vertical, we get customers that range from the city of London to here in California, and we cannot guarantee that carrier has these specific markets covered. We can't afford to wait for the carrier to deploy their network in these specific areas. So having a network that is controllable, that allows us to satisfy our service level agreements, or SLAs, is absolutely key for us, along with a low cost. Let's take a look at the next slide, Ed. Let's take a look at how the system works. I'll do this really quickly. Not that different from what Dominica showed. We have sensors that are installed on the streets, they're installed in garages. We have base stations, we have cloud services, and essentially the information, the knowledge, and the insight from all this data is accessed by web applications and mobile applications, both by owners of the assets and by consumers. We operate our sensors on a real-time per space basis, and that's key, because if you don't have per space, then you're really not solving the problem. One of the issues in this market has been that sensors have been developed in the past, but they were only 80 to 90% accurate. And apologize for the baseball analogy, but in baseball that's good, but in business that's bad, right? So we developed algorithms that allow our designs to be able to get up 99% plus accuracy which allows this solution to work. Data from our sensors is set from the sensors to the base stations, and then from the base stations through the internet to our cloud, and then analyzed by cloud services. Now, we provide three major values. There's a lot of little ones, but three major ones. The first one is wayfinding, as the industry calls it, which means getting the information of available spots to the drivers. Now, we believe in democratizing that data. So we provide that data to popular wayfinding applications and navigation apps that allow you to find the right open spot, saving you frustration and time. Second value proposition, paying for that parking spot. So it's really important that you have the least amount of friction in paying for a spot. We're not talking about going to a kiosk and finding your number or looking for a number on a parking meter or on a billboard somewhere. We're talking about pulling up, being able to pay with a single button and walking away. And we offer per minute accuracy on when you stay. You don't have to know when you came and you don't have to know when you leave. Very, very simple. The last thing we provide, and this is mostly for municipalities, sometimes for enterprises, is the fact that, you know, even after a couple friendly alerts, you still haven't moved your car. Frankly, there's turnovers that have to happen for merchants. Other people need to use the spots. We have a mechanism that provides for a way of overstay detection. And frankly, the old way of doing it with chalk, which is amazing, we still use this today, it's about 5 to 10% efficient, and we're close to 100%. Let's move to the next slide. So I'm just going to talk about a few quick case studies, and then we'll move it back to Ed. One of them is one in the UK with Harrogate. So very, very interesting deployment here. We're deploying the entire town, the entire city. So for a wayfinding app, this is fabulous because now anybody that's coming into this town can find a spot, frustration-free, anxiety-free. It's great for merchants. They don't have to deal with customers coming in being all upset about traffic and all upset about parking. They just come and go. Payment is being happened here. And again, this is a single touch walk-in park single touch payment and then drive away. By the way, this project is sponsored by Visa. So, you know, the payment backend is secure and trusted. Visa, obviously a good brand. And then, you know, what's interesting too is the city, for the first time, has data to be able to manage their parking. And again, before you have the data, you have no way of managing everything. Without metrics, there's no way to do that. So the city can look at not only real time, but go back in time and look at events. How did the town fill up? Did people use that parking spot in the end? Let's encourage people to use perhaps this parking spot in the back if they're long-term parkers or short-term parkers. Let's make their wayfinding, you know, go to those spots. Perhaps there's a high congestion area. And, you know, today our pricing is all the same. Well, we can manage pricing with surge pricing, dynamic pricing, different pricing, so that we can encourage people to use, you know, a lot that's a block off and try to balance that out so everybody gets a parking spot. Let's go to the next slide. So it's not just about municipalities. Enterprises have problems too. So here's another case study, a customer of ours, Arm Holdings, recently purchased by SoftBank. Here's a headquarters that has a big parking problem. Employees come in, they can't find a spot. Now here, well, they have open spots, they also have garages. So should I go to the garage? Should I go to the 5th floor? If I go to the 5th floor, where's the spot? So we provide, you know, highly accurate real-time guidance to that open spot so the employees can get to work, get in, start working as quickly as possible and not be frustrated. We also do some enforcement. So there, a lot of enterprises have customer centers where you bring in customers and have them, you know, look at your products and services, and you don't want employees parking there. So we can monitor that, again, 99% accuracy, and provide abilities to control the length of stay of guest parking, to control the length of stay at EV charging. People charge the cars for 4 hours and they leave them there. That's not efficient use of that. And in fact, we can even do carpooling compliance. So we can detect several drivers in the car and are both employees, and then you're authorized to use that spot. So just a couple case studies on how we're doing this. Again, LPWAN is absolutely critical for this application. Again, weightless N was the technology that we chose because of the cost efficiencies, because of the power efficiencies, and because we can control the network. So it's been my pleasure to share with you some of this knowledge. I hope you found it interesting. And Ed, back to you.
Thanks a lot, Paul, and Daniel and Domenico as well. So we'll just have really a quick wrap up to to provide a quick overview here. This pyramid is helpful to really put in context the the different options available based on the amount of bandwidth that you need for certain types of applications. Obviously, for video surveillance or electronic billboards, you're going to need a lot of throughput with connected cars and telematics. Again, there is the availability of power. So NB-IoT is actually works pretty well, but really at the bottom of the pyramid, this is where a lot of the really interesting new technologies that we've discussed, both LoRaWAN and NB-IoT, as well as a number of different flavors of proprietary technologies are available. And when you're looking to roll out networks for unique solutions, you're going to want to match the appropriate needs to the business case. So moving on, just a reminder for attendees that Momenta does produce quite a bit of content where we do try to bring as much insight and education to the market as possible. And we have a podcast that's now available on iTunes where we tap thought leaders really across the technology area. Our webinars as well are available on demand on our website, and as will this webinar as well. So with that, we'd like to go to some questions for the panelists. And actually, my first question will be for Daniel, and we'll take a minute. We'll do a little bit of a round robin here, and we'll see if we have one for the group. So for Daniel, what for companies that are looking at a broad array of LPWA options, how would you rank some of the most important decision criteria?
Yeah, so as you can imagine, that's my day to day with all the customers, and there's a lot of paralysis by analysis in the market. Should I go with narrowband? It hasn't quite been rolled out in my area yet, but I don't have to worry about a network, or I get a bigger ecosystem. So I understand the paralysis by analysis, but sometimes you just got to understand that these technologies are always pitched as being so much better in 6 months' time, right? And the real critical pieces of info is the battery life, the range, and then on a business sort of sense, what kind of business model are you looking to do here? Are you looking to pay a small amount every month based on the revenue that you're making for that asset? Or are you looking to make a CapEx investment and try to manage that network yourself and reduce your total cost of ownership? And how mission critical is the application? Because as I highlighted earlier on, if you really want mission critical, that sort of moves you into license band technology. But if you're looking for most of the messages most of the time, then you can achieve that in unlicensed band technologies. And that's the kind of guidance I tend to provide to the customers, along with a myriad of other things around security, scalability, and latency, and life of the technology.
Yeah, that's really helpful, Daniel. I have one for Domenico. Could you talk about some of the unique challenges that are involved with implementing LoRaWAN projects?
Yes, so I would say that in my experience in the early days of LoRaWAN, especially a few years ago, the maturity of the device ecosystem was probably the main challenge. Nowadays, I will say that many available solutions are available, ready to deploy, so it is not really a significant issue any longer. But early on, there were some issues with also the consistency of the devices and interoperability of devices with the network. But then with the certification program, that was overcome, and also the devices being ready for mass market type of deployment was a challenge, but not anymore in my experience. What I find now, if I were to mention another challenge in some projects, especially in some big projects in the enterprise spaces. We have seen that large integrators, many large integrators still have limited competence in the IoT space, which can really slow down some projects. And however, things are getting better also on this front. And I will say that in some cases, given our competence on the value chain and LoRa and IoT in general, we can take on some integration tasks ourselves to help the customers directly.
Great, thank you, Domenico. And I got a question for Paul about practical challenges implementing smart parking solutions. It seems like there are a lot of moving parts that are involved, and yeah, the question is really about some of the obstacles you face in just implementing the types of solutions that you've been successful with so far.
Right. Thank you, Ed. Yeah, there's probably three big issues that we've seen as we've rolled out these deployments and gathered these customers. One I'd put in accuracy, the other coverage, and the third is history. On the accuracy side, one of the issues has been a lot of companies in the past have put out some of these sensors, and they've been, as I mentioned before, 80 to 90% accurate. And it doesn't take too many false positives or false negatives as a consumer to look for a spot and gee, it's occupied, but it's not supposed to be. And that's really really been a big problem in the market. And so we spent a lot of time getting the accuracy up to 99%. In fact, just testing it to get to 99% is a lot of work. So coverage is another issue. And you can always say, well, let's just put more hardware out there. But the problem is, as Domenico just said, people don't want to manage this stuff. They just want the solution. They want the answers. And so we don't want a lot of hardware out there. Number one, it's hard to manage, and two, it's complex and expensive. We did a bake-off, for example, with a large customer up in Seattle that had 16,000 parking spots in 4 or 5 garages. Very difficult RF environment. And we won that contest because it only took us 4 base stations to cover the entire area, and our closest competitor took over 10 times that amount. And so, it gets complex, it gets expensive, it gets hard to manage. And of course, we manage our network for our customers, so it's easier for us and it keeps our costs down. And then lastly, I'd say, the history. Because there were some large, well-funded startups in this space that frankly didn't have the accuracy or the coverage, we're having to, let people know, hey, look, this is a problem that you've had for a long time. I know you tried to solve it, but give it a try. And what we found is that once they jump on board, then they're super happy, and everybody is getting value out of the solution.
Great, and I think we have time for a final question, which we're gonna give each one of the panelists an opportunity to answer. And it's a two-part question, which is one, what are you most optimistic about with these technologies, and what are the greatest risks ahead that you see? And for each of you, you can direct that toward your business or your area of specialization. And we'll just start with Daniel, and then Domenico and Paul.
Right, so what am I most optimistic about? Well, it took a long time to get to where we are now. A lot of different technologies where things like meshing had to be involved in order to get the range. Whereas now, we don't need all of that extra equipment, and we can be more efficient about what we're doing. And so now I really see that integration happening, the integration between the microprocessor, the low power wireless access technologies, the operating system that sort of melds it all together, and then the ability to really start placing that intelligence out into the edge. And with that becomes the manageability of the life cycle of that technology. This stuff's going in the ground in Paul's case at N-Wave for 10 years, right? Nobody wants to get a jackhammer out and start getting these things out. So the optimism for me is that consolidation and that ability now to be able to manage these assets during their life. And this is the bit that a lot of people don't really realize. It's one thing doing POCs and trials, but imagine having to manage these things for 10 years in ways in which you can't imagine right now.
Great. And Domenico?
Well, I mean, yeah, I'm an optimist by nature, which helps. But I will say that definitely the opportunity that I see in the marketplace, we have really in all regions and in each region hundreds of good opportunities of new projects coming up, and especially in the enterprise space, by the way, that is really the fastest growing in our view going forward. So there, I mean, this opportunity really makes us hope that the business will grow and is growing actually steadily. And this IoT will finally come of age in the next few years with these billions of devices that we all talk about finally materializing. In terms of risks, I think you were asking as well. I will say also that without a doubt, the main risk, although manageable risk, is the fragmentation of the market, in my mind, where it's really a central challenge for all companies in the IoT space, in my view. This means that the IoT vision of connecting these billions of devices ultimately requires bringing many different solutions to many different customers, in fact, in many different industries. The term IoT itself is a bit of a misnomer in this sense. And so the implication of this fragmentation is that in most cases, it is difficult to scale a particular business in the value chain very quickly as one you would like. And I mean, that said, I mean, it can be managed with realistic business plans and developments, and you can grow anyway.
Fantastic. And Paul, final word from you.
Yeah, I'm going to echo some of Daniel's and Domenico's comments here. You know, I was a general manager at Cisco for many years. We were involved with, you know, I'm not going to call it IoT. We didn't even call it IoT back then, but we did smart cities in Saudi Arabia and in India and Europe and all sorts of places, and we connected devices up. And you know, it took a long time to get this stuff going, as the other guys just mentioned. And I think, you know, being optimist, what's great now is we've solved the technical issues. We have you know, protocols that allow us to have very efficient you know, spectral efficiency. We have technology to go a very long ways. We have ways to do these sensors, and now we are able to get these deployments going, and I think it's fabulous. So I would echo some of the risk is, as Domenico said, you know, IoT is kind of like saying we're doing enterprise software. It is so broad. Industrial internet is very different from agricultural telemetry, which is very different than smart cities. And it's very, very hard to have, you know, one technology spread across us all. This isn't back in my days when I was pushing, was VPGM at 3Com and pushing Wi-Fi early days. You know, it's pretty consistent use case, high speed data, right? Let's connect people and computers. But this is different. We're connecting cows, we're connecting parking spots, we're connecting industrial machines. And so I think, you know, for companies looking at doing this, I would say, you know, the technology is there, pick the right one, but really focus on the value proposition and really understand your customer. It's not just about collecting data. It's not just about getting the knowledge. It's about getting the insights and making sure that the insights are valuable and people will pay for them. And I think if we do that, we'll see this market take off in many areas. One last point is security. One of my other positions at Cisco is managing all of Cisco's endpoints across the globe. And you know, we're going to have to make sure we do these all secure. We have the technology to do that. And we just need to, you know, if you're a customer, if you're a vendor deploying these technologies, let's make sure we keep the technology safe and secure so that the market continues to grow.
Great. Well, those are fantastic comments from all of you, Daniel, Domenico, and Paul. We're really you know, very grateful for your time and effort in bringing this content to our webinar, and to all of our listeners. Thank you so much. We will be making this broadcast available on our website, and for any questions, please reach out to me at edge@momenta.partners, and to anyone directly. Thanks again, and have a fantastic day.
Many thanks, Ed. Bye.
Thank you, Ed.
Thank you.
Thanks, Daniel.
Bye.
Domenico.